Hi, class. I wanted to help you guys through our virtual lab. So we're going to go to our Build a Lab simulation. So you'll open the lab document, click Make a Copy. And then to get to the simulation, you'll just click on this link, and then we'll follow the instructions here. So just a reminder that your labs are worth 30% of your grade, so it's totally worth your time, and these are actually really fun. So you'll click play, which will take you into the simulation. And the first thing says to go ahead and explore build an atom. So we'll go here and you can just play around. That's kind of what I really like about these simulations is you can't do this in real life unless you have like $1 million machines, like scanning electron microscopes. And even then you can't manipulate atoms like you can here. So it's really cool to just explore, see what happens when you add more protons, more neutrons, more electrons, uneven amounts of things, and just check out all of your different options here. So right now we're neutral. Neutrons will keep it neutral. Protons will make it more positive. You can add electrons to even that out again. See what happens when you add too many electrons. When does it change to a new element? So just play around with it. You don't often get to be like, hey, just go play around. But that's one of the cool things about science is you get to play around and discover. So I want you to go ahead and do that there and then list two things that you observed just playing with the simulation. What particles are in the center is your next question. And then play around until you determine which particles determine the name of the element you build. So right now we have beryllium, and now it's boron, and we added a proton. Does it change elements if we add more electrons or more neutrons? No. So that would be your answer, hint, hint. And then you'll find what's the name of the following atoms when you have 3 protons and 4 neutrons. So you'll just work through those. We'll reset it. We can do that pretty quickly. 3 protons, sorry. And then 4 neutrons. Okay. So there's your answer there. And then we're going to take away a proton to answer 4B and add 2 protons to find answer 4C. Now we're on to number 5. See how fun this is? So we get to play more with the simulation and discover which particles affect the charge of an atom or ion. So you probably observed that when you were playing around. So we have a positive ion because we had no electrons, and now we still have extra positive protons compared to electrons. So then we need to add more to make it a neutral atom. You could also add even more electrons to make it a negative ion. Okay, so that should take care of 5. All right. Then we need to write or develop a relationship in the form of a single sentence or equation that can predict the charge based on the numbers and types of particles. Okay. So essentially, this net charge is what you're going to be writing an equation for. Okay. So it'll be the number of protons minus the number of electrons will give you your charge or something along those lines. So on to number 6, we get to see what affects the mass number on our atom or ion and write a rule for determining the mass number. So that's where you'll focus on this section. So you'll go ahead and just add and see what increases that mass number. It's very unstable there. We'll talk about stability next. I probably should turn that off for now. So as you can see, I'm not letting me grab that. As we add more protons and neutrons, each one of those increases the mass number by approximately 1. So say number of protons plus number of neutrons equals mass number. Pretty simple there. On to number 7, we get to play the first 2 levels on our game screen. So you go down to the bottom. Sorry, this is kind of hiding it. But you'll go to the game one. Here, we can go home so you can see it from here. So you'll click on the game. And then you'll just play the first and second levels. You can choose your games. And yeah, so that's number 7 is just playing those. Number 8, we're going to create a definition for element symbol, charge, atomic number, and mass number based on beryllium. Back to our page here. Okay, so you'll write, okay, the element symbol is Be, the charge is 2 plus, the atomic number, and then the atomic and the mass number. So you can just kind of bounce back and forth if you wanted to play with those. You can go to the symbol option. Will let us select? No, you have to actually make it. So I'll go ahead and make beryllium. There we go. So the one I have up there is beryllium 9. Okay, 4. Well, we need to add our electrons so that we get to plus 2. There we go. So that now matches the one that I have on your paper. So you can see what each of these terms mean. So you can describe it. Beryllium, or this particular beryllium or form of beryllium, has 4 protons and 5 neutrons. To create the mass number of 9. It has 2 electrons but because it has 4 protons, it has a +2 charge. And then the atomic number is 4 because it has 4 protons. And then the elemental symbol is Be for beryllium. Okay, so let me know if you have any other questions about that, but it's kind of nice to be able to create it and then actually see like, oh, where did they get those numbers? So I know it helps me to see it visually, so that's why I like that you guys get to do these. And that's why they're worth so much, because it's so valuable to get to work with it. Number 9, you get to play the games a little more, kind of on your honor system. Number 10, we're going to represent atoms by name and mass number. So we're starting with carbon 12. You'll write the symbol for carbon. And you get to choose the other ones that you do. You don't have to like keep doing different carbon versions. So you can do the game one or come here. I would go to your symbol version. Here, I'll go home so you can see it. Go to symbol and go to carbon or carbon 12. Do we have enough? Yeah, okay. There we go. There's our carbon 12. I'm not sure if it's stable or unstable now. It's good for you to start playing with that at this point. I'll grab what I want, please. Okay. Now we have a neutral carbon atom. You could take one away and do boron. You'd say boron 11, like the carbon 12, and use the symbol as B. You can take away even more protons, or you could add more protons. I would focus on doing stable ones, so add more neutrons as well, because the stable ones are more readily available, or ones that exist. I guess would be a way to think about it, are more likely to exist beyond a lab setting where they've manipulated them. So then you could do nitrogen. So nitrogen 14, atomic symbol N. So those are a few options. You can go all the way down to helium if you want. That's totally fine too. Now, for part 10b, it says each representation, symbol, and name in the table above provides information about the atom. Describe the similarities and differences between the symbol and the name and what the name represents. So I would probably say something along the lines like the symbol is just your He-Libe. So carbon 12 gives us more information, or nitrogen 14 gives us the actual name of the atom plus its atomic mass. It's kind of all I would say there. So we're on our last part. We're going to dive more into stability. Sorry, I got ahead of myself because I couldn't help it. You get to play with the simulation to determine which particles affect the stability of an atom and which don't affect it at all. And then you'll come up with different names of the stable forms of oxygen. So while we answer that first one, we'll go ahead and get to oxygen. So there's oxygen 16 is the first one we're starting out with. So you can add 17 stable and 18 are stable. You'll list all the things that are same, ignoring the electrons. So focusing on what's the same number of protons. Sorry, don't want that. The electrons, I mean, they could have been the same. You can also have them different. We'll explore that a little more on how electrons like to jump around. If they're on the outside, they hop around to different atoms. But we'll look into that. That's a whole nother lesson and unit, static electricity and all that fun stuff. You can try to go backwards. So we started with 16. You can see, okay, 15's unstable, so that one doesn't work. We can go ahead and try to go to 19, see what happens. Notice that if we change the number of protons, then it's no longer oxygen. So the thing that makes it oxygen is the number of protons, which would be 8, your atomic number. Okay. So we played with that. And then you can list the things that are different, i.e. the number of neutrons, which affects the atomic mass as well. So that has 2 things that are different because the number of neutrons also changes the atomic mass because they each have a mass of 1 atomic unit approximately. Last question. The atoms in the previous questions are isotopes of each other. Based on this information, list requirements for 2 atoms to be isotopes of each other. And basically, that's almost the same thing as 12D. So go back and look at what you put for 12D or what we talked about for 12D, and there you go. So hopefully you found that helpful. I know I enjoy playing with it, even though I've done it before. And they're not too hard. See, you could totally do this. Reach out if you do have any questions, but I hope you had fun kind of playing and getting a better understanding because I know it helps me. It's a good reminder and helps kind of, I don't know, give me that more concrete understanding of what could be a very abstract thing because they're so small we don't normally get to see them. So I hope you enjoyed it and have a great day.